properties, but we're also branching out now into some electronic properties as well. And my group is really interdisciplinary. So I'm actually a physicist by training. All my degrees are in physics and math. And I have students from material science and engineering backgrounds, chemistry backgrounds, physics backgrounds. And I also have appointments in other departments on campus. So for me, science and engineering is a big tent. And that's one of the exciting things about UC Irvine, that it's so interdisciplinary.
Great, thank you.
Hi, I'm Salma Elmalaki. I'm an assistant professor in electrical engineering and computer science department. Also, this is my second year at UC Irvine. I think me and Stacy joined almost at the same time. My research is focused on autonomous computing, cyber physical systems, and embedded systems. And I'm very interested in how we can actually model the human inside the smart system. How can we predict the human intent, the human behavior, the human preference, and based on that, how can we adapt to the environment around the human in order to meet the human expectations and needs. I don't have a joint appointment, so all my students are in electrical engineering in the computer science department. Thank you.
Thank you, Professor.
Hi, everybody. Well, thank you for having me. My name is Limnitzer. I am in the civil engineering department, and my research is in structural and earthquake engineering. I have been at UCI for a little bit longer. I joined in 2011 and went through the whole tenure track and became associate professor in 2018. Before that, I was actually 2 years at Cal State Fullerton. It's for those of you that are familiar with the university, it's more a teaching oriented university. And then I switched back to a research school because I really missed doing some research. And I do a lot of traveling. We travel to all the earthquake regions. We do a lot of earthquake reconnaissance. My research is mostly experimental. So if you see anything shaking, cracking, collapsing, and making it's a dangerous noise around the engineering laboratory, it's probably one of my specimens. But yeah, so we're looking forward to getting actually back in the lab and continuing. And thank you for organizing this today. I've never participated. This is very cool. I'm looking forward to this.
Yeah, we're happy to have you.
Likewise.
So we'll be going into some pre-prepared questions that we've had, and then we'll save some time at the end for audience Q&A. So some of you have already gone into this a little bit already, but could you each tell us a little bit about what you did before you joined UCI and a little bit about your background?
Do we just want to go in the same order? Stacy, do you want to start again?
Sure, that's fine. And
Okay.
This is Lydia, by the way. She just got back from school. Can you go downstairs, honey? Or you can sit here. So I said I got my degrees in physics and math in undergraduate and graduate school. And then I went and did a postdoc fellowship at the National Labs. Specifically, I was employed by Los Alamos National Lab, which is a Department of Energy lab, in kind of a unique position in that I was working offsite at Sandia National Lab. So the Nanoscience Center is joint between the two, and I happened to be stationed at the place that didn't employ me. And I spent about 2.5 years there. That was kind of my bridge from a very physics-oriented background to a more multidisciplinary research environment, where my mentors were people from the engineering sciences and then from biochemical sciences. And I worked with students and postdocs from all kinds of disciplines. So I think that experience working at a national lab was really useful because it gave me a view of what engineering and science careers look like outside of academia, which is of course what most of our students will go on to do. And also it kind of erased those disciplines that we learn about in academia, where people feel siloed into one department or the other. That really doesn't exist in the real world. So it was really neat to get an experience working outside of that environment. And then I returned in fall 2019 to academia because I really love teaching and I really love mentoring students as well.
Okay, for me, I first was in industry for 3 years in one of the international CAD companies called Mentor Graphics. Now it becomes a Siemens business. And after I stayed in industry, I think for 4 years after my bachelor, I decided that this is not for me. I want to do research. Okay, so I decided to apply for a PhD, and I went to UCLA and I got my degree in electrical engineering and computer engineering there. And after that, I didn't want to go back to industry, but to be honest, I wasn't really sure if going to academia was the right step for me at that time. So I worked in not industry, but more of a research institute. So I worked at Microsoft Research, MSR, and then I went to Janelia Research Campus, which is the main research institute for Howard Hughes Medical Institute, where they needed researchers in computer science and computer engineering to help neuroscientists at that institute. And it was for me, it was out of my comfort zone because I needed to work with neuroscientists. And actually my interview was in an office where they had like a Nobel Prize in that office, okay, from a neuroscientist at that place. So it was an intimidating interview at that time, but it was an interesting experience for me, to be honest. I worked there for 1 year to analyze the sleep pattern of a Drosophila fly, which is completely out of my comfort zone. And after 1 year there, I took the decision. Now it's the time to go back to academia. And like Stacy mentioned, I like teaching so much, and I really enjoy teaching. And it makes you feel young. And when you say something and you see its effect on the students, you can't see that in any research institute or any industry. When you say something or when you explain something and you actually see its effect on the students and they really understand what you said, it has like this personal satisfaction. Okay, so I really enjoy teaching, and this is one of the reasons that maybe one of the main reasons that I came back to academia, because at research institutes I do research, but in academia you do research and teaching at the same time. Yeah, here I am at UCI. I took the decision and came back. Yeah.
I have to add, teaching at the college level is probably one of the very few jobs that's going to keep you young for a very long time. That's what my PhD advisor once told me, and I realized it's true. So I already told you a little bit about myself. Also, I have to say, go Bruins! I graduated with my PhD from UCLA too. So it was
Bruins.
It was a fun school to attend. After that, I wanted to become a professor, but I thought I was scared of having this huge research responsibility on my own. And so I ended up taking a job at a teaching school. And after 2 years, I realized now this is, as much as I love teaching, if this is the only thing I have to do, no, I don't want to do it. And so that enthusiasm for teaching that I had in the very beginning was kind of going quickly away. And so that's why I reapplied, and then I came to UC Irvine. In between that, I took a guest professorship at the University of Chile in Santiago, and I was there for several months. And there's something probably one of the craziest decisions professionally happened, because in a spur of drinking too much pisco sour, a few of my colleagues and I decided to open a geotechnical company in the continent of South America. So that was, I don't know how it got to that point, but 10 years later, the company is still running and it's expanding like crazy, which I've never thought. I had to learn Spanish in the meantime to just, be able to do anything on there. I didn't know Spanish. I had, German, English, and French. That's the traditional languages you learned growing up in Germany. And so, yes, so that's is something that I would not recommend entertaining while doing a tenure track. It's a lot of multitasking, but I'm glad I survived it, and then I'm here since 2011, and yeah, associate professor since 2018.
So our next question is, what inspired you to become an engineer?
So actually, I wanted to add on something from the last question, because I should have mentioned about my life before graduate school, since this is for undergraduates. I actually grew up in New Mexico, and as a kid, I really liked nature, and like being outside. Plants and animals were fascinating to me, and I wanted to study them. And then when I took physics and math in high school, I realized, oh, I'm quite good at this, and I think I actually kind of like it. So I wanted to do biophysics in college, but it wasn't a major at the school that I could afford to pay for. So I did physics, and I worked in a biophysics lab. And then that started me on the track of, thinking about research as a career. So sorry for not backing up a few more steps. But I think that's also related to what inspired me to become an engineer. And I'm actually still learning to call myself an engineer, since I'm new to the engineering field. But I think what inspired me was this obsession with nature, this fascination with how complex and dynamic and really honestly quite beautiful living things are. And so for a long time, I was just interested in studying them to understand biology, understand how living things work, things about plants and animals. And then as I got further into my undergraduate studies, and I was studying physics and math, I got really interested in how can we understand based on physics how life works. And then it was at the end of my graduate career when I started thinking about this idea of bio-inspired materials. So I now understood a lot of things about life and the little machines inside of our cells, and how things like photosynthesis work. And I became really intrigued with this idea of if we could make materials that are like living things, then we could, transform all kinds of technologies. So I think since I became an engineer later than most people, that's really what inspired me and continues to inspire me in my research to this day.
Okay, for me, well, I have always wanted to be an engineer. Okay, since maybe elementary school, and that's because my family, all of them are engineers. But at the beginning, I wanted to be a chemical engineer, and that's because my father is a chemical engineer, and I was obsessed with organic chemistry, and I really wanted to go into this field. But then in my I remember, I think in the second year of my undergraduate studies, I took a class on AI. Okay, and that was like completely shift my interest, and I started to be obsessed with computer science and knowledge based and algorithms and machine learning and compilers and these topics. I decided to continue in computer systems, but when I was in Egypt during my undergrad, and I continued to be an engineer. It was never actually a different track for me, since like I'm in elementary, all my brothers, my father, all my family are engineers. So it was kind of what was in front of me, and I like the field. So yeah.
That's very similar for me too. My mom and dad are engineers, and then they have their own engineering consulting office. And so back in Germany, I felt like, oh man, my sister is on a totally different side. My sister studied fashion design. She works for UVEX, that's the company that you might know from the Olympics, when in the winter with all the helmets and the gloves and all of that stuff. So she she is with them. So I was like, I guess I'm the only one that has to take this over. And well, I studied civil engineering. My dad, originally proposed, let's do architecture for you. Maybe that's more fitting for a girl. So I took the architecture entrance exam and I totally failed. They told me you're not creative enough for this, like go do something else. So I told myself, if I can teach myself creativity and know the engineering part, I can do both on my own. So I ended up studying civil engineering, and that was the end of that. But I ended up being here. So to this date, I have not taken over my parents' company yet, which I still feel a little guilty about, But well, we'll see how that's going to turn out. For now, I'm here and I'm enjoying what I'm doing.
Thank you. So our next question is, why did you choose your particular field of engineering?
So I guess this is related to what I described before. I was always fascinated with life and living things as a child. And most of the things I wanted to be as a kid were related in some way to that, whether it was, study animals or be a veterinarian or something. Although I don't think I had this, one specific goal in my mind from the time I was a child. But this interest in biological materials is what led me to where I am. So whether it was understanding biology from the lens of physics or understanding biology from the lens of materials. So how can we make materials which use components from biology or which are inspired by biology? These are the things which really excited me. But I also sat down once and I thought, what is it about what I do that I love the most? What drives me? And I think part of it is that interest in biology, but another part is that I'm really interested in science that I can see. So things which look, visually beautiful to me really excite me. So a lot of my research has to do with materials that create or manipulate light in some way. And I think the reason why I'm driven to that is because I can see it, right? I can create this nanomaterial in the lab and it's glowing a particular color. Or in the past, I did some research on how we can use ultrafast lasers to create plasma channels in air and other media. And it would create these beautiful rainbows of color because of this interesting effect where you get light emission and a white light spectrum out of the material. And I just remember that being so exciting. And I also loved any kind of research where I could see the material I was making, either because I was doing microscopy or some other technique which gave me a visual picture of what's going on at the nanoscale. So I think that's really what drives me to be a materials scientist or materials engineer, is to be able to see an actual structure and then understand how its properties arise out of that structure. And then, my fascination with materials that create and manipulate light.
So I actually maybe the same thing as Stacy. So what I like about engineering in general is that I can I can see what I'm doing. I can see the experiment. I can drive the input and see the output. So especially in electrical engineering and computer science, the output is, you can see it, you can sense it. This is why in general, I like engineering fields. As why electrical engineering and computer engineering in particular. So let me tell you this story. So while I was at Jamelia Research Campus, so there were seminars that neuroscientists give to us, to all the research center. And the way that the seminar was done, these are like scientists and high category, high impact scientists in general. And the way that they conducted the seminar was saying, we tried this experiment and we saw this observation, but we really don't know why this happened. Okay. And that was, for me, it was really annoying. And I think that's because of the way that I was trained in my field, is that you say a hypothesis, you make an experiment, you get a conclusion, but you have to explain why you get this conclusion or why you saw this result. It has to have some kind of a logic. You have to drive the logic itself. But in other fields, this is not really the case. So I don't think that I can flourish in any other field that doesn't have this logical thinking and logical hypothesis and steps. So this is in engineering in general. But why electrical engineering and computer science is that the results of your experiment is logical and it's based on steps, and you can actually explain your hypothesis. So I like the structured fields in general. So yeah.
I think I probably answered part of this question, why I am in civil engineering, which is, you know, stems out of this partial family obligation that was there in the very beginning. What I studied, though, however, at UCLA was more, I got my degree in structural engineering, and here at UCI, I primarily do geotechnical engineering. Towards the end of my PhD research, it was really, we were doing a lot of work on bridge foundations, those huge piers and pillars that you see on those freeway overpasses, how they behave during earthquakes. And so it's kind of a research that bridges both fields. And when UC Irvine was actually looking for a faculty, because they didn't have a faculty in the geotechnical field for almost 6 years. It was just filled with outside lecturers. They needed someone who actually is kind of in between, because as of today, I am still the only professor in geotechnical engineering. And so I do cover all of these fields, but I can closely collaborate with the rest in the structural engineering group. And so that's kind of how I ended up in this very particular niche that bridges both fields. But it's a unique and fun situation to be in. And so it also allows me to have much more collaboration and interaction. So this is where I come from.
Thank you all so much. Moving into a little bit more of a fun question, we'd love to hear what your most enjoyable project or just professional experience that you've had has been.
I wish I didn't have to go first every time. So I don't know if this will be the ultimate experience, but one project which has been really enjoyable and has actually extended from the beginning of my PhD until going on now has been focused on these nanomaterials called DNA stabilized silver clusters. So these are the tiniest of nanoparticles where we can actually count up the number of silver atoms. And we have about 10 to 30 silver atoms in a little bunch surrounded by a cage of DNA. And these materials are really cool because they're highly fluorescent and they're very promising for applications like biosensing and bioimaging, among other things. They're also really neat because DNA is a sequence programmed molecule. And we can't really create anything like this synthetically. So it has the sequence of ACGT that encodes our genome. it turns out that the specific sequence of the DNA we use also picks the color of fluorescence of these silver clusters. So in a sense, the DNA is acting as a genome for a nanomaterial. But this is a really complex connection between this fluorescence color that you can see the tube glowing with and the DNA sequence that you put in. So these materials, I started studying them as a PhD student, and I remember being fascinated and frustrated that we couldn't understand this genome for this nanomaterial. And I had started to read about machine learning and other types of data-driven techniques. And so I was thinking in the back of my mind, you know, maybe we could use some kind of machine learning or data-driven approach to understanding this problem, because from first principles, so meaning if you just wrote down all the physics equations and brute force threw it in a computer, it was completely impossible from a computational standpoint. And one of the reasons why this is really fun is because I had an undergraduate working with me at the time. And his name is Mark. He had come from a community college and then transferred into UC Santa Barbara, where I did my PhD. And we had an effort in my lab to give community college transfer students research opportunities. So he was really talented and really creative, but a terrible, terrible lab scientist. So I had been tasked with trying to teach him how to make these silver clusters, and I was just seeing that this was not going well. You know, some people's thing is just not in the lab. So we were walking back from a building where we had done an experiment together, and it had just totally bombed. He had, you know, I could tell this was not really his thing. And then he just started talking about how he had been reading about artificial neural networks, and he was thinking that we could use them to understand the sequence color connection of these nanomaterials. And I got so excited. And I said, okay, stop. I've been thinking about this too. We have to go straight to our advisor's office, and we need to talk about this with her because this is so exciting. And so we went together. And she was hesitant at first, but we ended up convincing her to try it. And, you know, several grant proposals later, now this is a big component of my research today, where we use still machine learning strategies that are getting more complex in order to design new DNA stabilized silver clusters for applications. So this was fun, one, because it was an idea that I had, which was considered crazy at the time. People didn't use machine learning in physics, at least experimental physics, much. But two, this undergraduate from a really non-traditional background had a critical role in, you know, catalyzing me to be brave enough to bring this up to my advisor. So I think any project that I work with a really creative undergrad or graduate student on is a lot of fun for me.
Okay, so this is a really tough act to follow after what Stacy said. Okay, but for me, maybe the year that I spent at Janelia was for me very challenging and enjoyable, because, like I mentioned, it was out of my comfort zone. So one of the experiments that I was doing was actually, like I mentioned, I was analyzing the sleep pattern of a Drosophila fly. So I had built this kind of like an equipment where we rotate a fly inside tubes, but the rotation itself is adapted based on a certain algorithm that I wrote. So I was monitoring their sleep pattern, their eating behavior, and I divided the flies into male and female flies. And then by the end of experiment, I noticed that the female flies don't sleep and don't eat well. And yeah, and that was for me, okay, this is maybe like it's general for all species, but yeah, but it was a fun thing for me. And then I reported that to the neuroscientist at that time, and he mentioned that there was certain circuitry in the brain of the female that is different than the one from the male, and that it can affect this behavior. And we were interested in detecting this using techniques from algorithms and machine learning. So that was a fun result that I found. And during my time at Jamelia is one of the reasons now when I'm at UCI, I'm trying to actually collaborate with scientists at neuroscience department, and we have a joint project together that tries to understand how the brain works to actually acquire new knowledge or learn new information, how the brain signals changes to detect, for example, if you actually learn the concept that is being presented to you, or you are frustrated and you're not learning anything. And the objective of this is from computer engineering perspective is that I want, for example, to adapt the learning environment in a personalized way based on how each human brain is working, which is a very personalized experience. So I think without my professional experience at Jamelia, I will not be that comfortable to collaborate with neuroscience department on this particular topic. So yeah.
I could use some AI algorithms too for my research. just saying. I don't think I have one most enjoyable project or so. Since most of my experiments is really big, large scale, I was able to just participate in so many cool projects and also lead very big ones at UCI. I think it was always the challenge of something that hasn't been done in that same size and scale before. When I did my first project in the big laboratory, in the engineering laboratory facility, that big structural testing hall, two of the faculty said, no, you can never build something like this. You're going to break the whole hall. You're going to be responsible. It's multi-million-dollar repair type of thing. Don't do this. It's still standing today. So this obviously went well. But other than that, and I've had many of those enjoyable projects, the most fun part is actually doing construction work together with my students. And that's part of, a necessity because we don't have that lab personnel that can teach the students. So I'm at the same time like the faculty and the lab manager and the construction person and the purchasing person and the installation person until, students learn and can do it on their own. But it's been fun. But then other than that, I think one of the nicest things too is the ability to travel and to do international work. It's hard to beat a professional experience when you get invited for a keynote lecture in Cancun or in New Zealand. And I just have to be honest, it's like the nice benefits of that come with a nice technical conference. Not to diminish the technical content, but it always helps if it's in a really nice location too. So.
Great, thank you. And our next question, what are some important lessons that you've learned from your career thus far? And you all can answer in any order that you'd like.
Okay, I can take the lead so I can give Stacy some break. Okay, so the most important thing is not to compare yourself with others. Through my career, I had to make a lot of compromising for my kids, for my marriage, for my family. And if I kept on comparing myself with others in the same field, I will be devastated. Okay, so I can't, just to give you like one sentence, I can't be the best researcher and the best wife, the best mother, the best daughter all at the same time. Okay, so the best friend. Okay, so I have to make some compromise. Okay, and when I reached that conclusion during my PhD, that I can't do everything, because when I was doing my PhD, I had my son, and at the very last year of my PhD, I had my daughter. Okay, so that was a tough experience for me. But at my second year of my PhD, I took that decision that I can't do everything. Okay, I have to enjoy what I'm doing, and I have to stop comparing what my achievements to others who are not in the same place as me. And actually, when I did that, my accomplishments actually in my research was much higher, because I removed that stress from my head. All my awards, all my best papers, all my talk came after I reached that conclusion, and I stopped like the stress of that. I have to have these number of papers, I have to do this, I have to get this award, I have to go and give this talk, I have to talk to this person, and this all stressful environment. When I stopped that and decided, okay, maybe I can skip this deadline and go outside with my friends. I can skip this deadline for a proposal and maybe spend this week with my family. Okay, I don't have to do everything and compare myself with everyone, because at the end, yes, career is important for me, obviously. Okay, but it's not the only thing in my life. So I the problem with me at the beginning was that I was trained and was raised up to be the top. So during my elementary, during my high school, my parents always pushed me to be like the first on my class, and I like always be the number one or the top on my class. Even in my undergraduate studies, I was like the top of my class. So when I entered the PhD, in order to be the same while I was married and have a kid, this was not possible. Okay, and that took me, like, it shaped me, because when I entered the PhD studies, okay, why I'm not the top? Okay, I've always been the top student. Why I'm not number one? Why my paper is not the best paper? Why my paper didn't get? Why I got these bad reviews? Okay, and it when I reached this conclusion, I think in my second or third year of my PhD, that okay, I can skip this and go to my son event in his school. Okay, when I did that, it really affected even my career positively. So that's my advice to everyone, actually, that your career is important, but your mental health and your other things in your life are important too for your career. So yeah. This is it.
That's very well said. I wish I would have known you during my PhD. It was similar, and I think it's a very common thing, especially for females in engineering, what I have noticed. And especially if you're in a high pressure environment such as academia, and especially during tenure track, there's the fear of failure and what do others think of you. And and that's more so, much more so with women than with men. Men don't even think twice about what others would think about them, like what we do, and constantly try to have to prove ourselves. And I noticed that now post tenure more. During tenure, I was so stressed out. I had this exact same fear of failure, and I waited with kids afterwards, which I now think, why did you do that? And but I noticed women think they have to submit 100 or 200% quality work. They submit it, and then they still feel like, oh, was this good enough? Is this going to be, what other people think of me? And men submit 70% of the same quality and are 300% more confident and just say, this is my thing, and then they just appear like, and we're like, okay, I could have done the same thing too, but I just, spent 3 hours worrying about myself and the impression. So that's it took a long time to realize that. But I've written the whole section on this, and we're still trying to do like some workshops on this with the Office of Outreach and Inclusion for the NSF career proposal. And there's a lot of research that can support this. So what I would recommend is, like, study hard and be good at what you do, but then let confidence kick in, because You know, others submit half the work you do with twice the confidence. So.
Those are really, really good suggestions. Thank you. And I think mine is related in that one of the most important things I've learned is that failure is actually critical to research and engineering outside of the research fields, because the best ways that we learn are by failure, right? We try something, maybe you do an experiment or you change your design and then you see what happens. And that failure you then learn from, and then you iterate on that. Maybe you learn something new about the science or you make your design better. But when we're so wrapped up in getting the best marks on our exams, on getting into the best schools or getting the best job offers, we can really begin to develop this really paralyzing fear of failure that makes us not as good at being engineers. So I think recognizing that failure is a natural part of our job, we're supposed to fail, and then we're supposed to figure out why, and then we're supposed to do better next time. And letting yourself fail and letting yourself learn like children do by failing and then trying again. Kids are not that afraid of falling on their faces and then doing it over and over again. We should be doing that too. And I think that that's important in your studies as well. If you do an assignment and you don't get the best score on it, learn from that. The most important thing about any kind of assignment is not the grade you get at the end, which is really hard to understand as a student because you get this transcript with all these numbers and letters on it, right? But the process of learning, of making yourself say, hey, I got a B on this, what can I learn from that? Or, gosh, I'm doing this exam and at the moment I'm so stressed out, I don't know how to solve problem 2A. Just stop and say, whoa, okay, this is ultimately a learning experience. What can I learn from this? Then I think that liberates you to be much better as a student and whatever you do beyond school.
Yeah, I want to add on Stacy on that failure is the best thing to learn from my experience. So one of my actually best paper or my best piece of research that I had that received multiple awards was actually rejected twice. Okay, and I remember the first time I got the reject for it, and I still remember the moment when I received the rejection. Okay, and it really annoyed me. And if I gave up at that time on this piece of research and I haven't improved it or learned from the reviews and just be stubborn, okay, they didn't like it, I don't care, I would work on another thing, it wouldn't have developed into be this nice piece of research that I'm still continuing on it, and it got these awards afterwards. So like Stacy said, that failure sometimes is the thing that can push you forward.
All right, thank you. Our next question is, throughout your academic and professional career, were there any moments where you felt like you didn't belong?
Yes. I think this isn't probably supposed to just be a yes or no question, but I think that as somebody who got all my degrees in physics, the gender imbalance there is pretty similar to engineering fields. And I know it varies a lot depending on the field of engineering you're into, but it's probably similar to something like electrical and computer engineering where there's very few women. So for some reason, this didn't really bother me that much until I was a junior in college. And then it occurred to me that most of my classmates, the overwhelming majority, were men, but also actually all of my professors that I'd had in math and physics up to that point had been men. And I was starting to think about what I wanted to do after undergrad. And I realized I really liked the research I was doing in this lab. I really wanted to go to grad school and probably work as a researcher someday. But I had no idea how to do that because I had only had these professors who were men. So I think that was kind of my moment of crisis, I would say. I'm not sure what you call it, but that the moment where I realized, wow, this I don't look like any of the other people that I see doing the job I have. And so it was challenging to get through that without a direct role model.
I think that this can be, I mean, general. I think everyone will face during their career moments when they feel like, what I'm doing here, okay, this is not my place. You doubt yourself. I mean, these are, I think, are all natural human experience in general, in anything, that you sometimes doubt yourself, sometimes you feel that you don't belong. But I think what matters at the end are like the people around you who can like ground you and tell you that you are doing a good job, you belong. I mean, you can't live all by yourself. So you really need, like Stacy said, you need a role model. You need someone to tell you that you are good enough, you are doing a great job. Even if you are very confident with what you're doing, still you can't do everything by yourself. You need someone to give you this positive feedback. Okay, so I think that this is common, and I don't think that this is something that can be considered as a negative feeling in any way. I mean, it's normal to feel that in general, that if you don't feel like that, then maybe you are so proud of yourself. So I think this is something that I think it can be applauded, that you sometimes you doubt yourself, that you try to think, do I really belong here? Is this something that I want to do? If this is the right decision? And you can ask around and take advice from role models or advice from other advisors around you. But of course, I doubted myself several times, and I asked myself, is the PhD the right thing for me? Is this topic the right thing for me? Is this collaboration the right thing for me? So you will always ask these questions to yourself. But I think this is a normal feeling.
Mm. I agree. I have a more specific example, but I'm going to wait until the next question because it kind of ties in exactly what the next question is.
Okay, yeah, so our next question is, did you ever feel discouraged during your academic career? And if so, what kept you going / inspired you to not give up?
I guess I can go, since it goes with, do you feel you belong here? And, you know, that is that feeling of discouragement. I've had two of those that I distinctly remember. One was during my PhD, and I came to the United States as a Fulbright scholar, but the school I came from in Germany was not strong on teaching computational methods. So when I was at UCLA, and everyone around me knew MATLAB and was like the coding expert, and I didn't even know how to open the program and what was the first command, you know, and it's like basic stuff. I was like, oh my goodness. So I'm going to share something that you can't share. So the homework for that quarter in finite element analysis, all assignments were not done by me. But that was like the lowest of the lowest point. And I thought, this is not for me, I have to quit. And then someone told me, just because you're not good in this one specific thing, doesn't mean you can't do the rest of engineering. You don't have to do research in only coding a finite element program. There's so much more to it that you could be really good at. And so that was, you know, not the most ethical method to get through the class, I admit, and I ended up learning it, but I didn't have the time to catch up on 4 years of coding that everyone else had, while I had 0. So, you know, it took me a long time, and eventually, you know, believe it or not, my first teaching assignment at Cal State Fullerton was to teach MATLAB. I thought, my goodness, karma is gonna come after you. So, so then I had to learn it because I had to teach it to the students. But by then I was, you know, much more advanced. But it's just a simple example. And I've had another incident where I was during my mid-career review during my tenure track, and I've had some projects, but it was not going so very well in the beginning. I had a much steeper takeoff after that, and I sat down with the department chair, and the department chair said to me, well, you know, back then I'm the one that hired you, but I'm not so sure about you anymore. And those words hit. And he pretty much said, we're not even sure if we want to let you pass a regular merit review at this step. And that was just so devastating, because that's pretty much him telling me prematurely, I don't think you're going to make tenure, or you can make it here. That was the end. I think that took me a few months to recover from that. And I think the thing that kept me going was not the wisest motive. I was so afraid of failure and what everyone else would think in the department of me if I couldn't get this to work. So I kept trying and trying, but it ended up being one of those programs that I did, the faculty development or the faculty success program, from the National Center. And they address all those issues that also Salma and Stacy talked about early on. And it was very, from a psychological perspective, very liberating to hear you don't have to be perfect, or you don't have to work 18 hours per day to get something done. It's not helping. And after that, I kept going, and things improved, and I won one grant after the other. And right before I went up for tenure, after getting rejected twice, I won the NSF career proposal, which is pretty much the saver for anyone. And it's a huge reward, because only funding rate is 2%. And then I was, I felt like, oh, I showed him, or I showed them. But it was very discouraging in the beginning. And I think to have the right people there in your life, and also colleagues saying, everyone feels like that, just push through, it's not unique to you, is what helps in those moments. But to find those mentors and advisors with that wider look, with this broader view, is hard to find. And I have this later on as a note to myself, like when you say, what advice would you give? I say, get one mentor that's at least twice the age of what you are. It gives a totally different perspective. And maybe get one that just went through whatever you have to go through next. That's a good combination. It's a good combination to keep moving forward, wherever you stand in your professional career.
So my experience is related to what I previously described, where I realized that there really weren't people who looked like me who did research in materials physics or related subjects. And one thing that kept me going is that my now husband, who's my boyfriend at the time, I still remember him telling me this. He said, sometimes you can't find a role model like you because you have to be the first one. Mm-hmm. And that really has stuck with me. And we've stuck together too, obviously. So I remember thinking, okay, maybe I can't find, a female physicist at the time who looks like the kind of physicist I think I want to be. But maybe if I, broaden my mind a bit and just think about women who are professors, because turns out I could find some women who were professors who I'd taken classes from or interacted with. And then I ended up actually interviewing one, like an informal thing I just set up with her, because I knew that she was in, I think, international studies, and I interacted with her through the honors college at the University of Arizona, where I got my bachelor's degree. And I knew she had kids because she had pictures of them in her office. So I just asked her story, and it turned out it was really incredible. Like, her husband had survived brain cancer, and there were all these crazy things that she had accomplished. So sometimes if you find somebody who's inspiring and maybe they don't look like the kind of person you want to become in terms of career, but broaden your mind a little bit and ask them out to coffee when that's a thing again. And ask them what they did to become successful, and then think about how their strategies can help you, and maybe you can become the first role model that looks like you for people that come after you.
I think I can't add much to what Stacy and Anne said. But I mean, through my career and through my life in general, not just academic career, you will face people who will discourage you in whatever you do, right? Not everyone will give you a positive feedback, definitely. And like it or not, there are some people who may not like your success. Okay, and that's a fact that you will face through your career and your professional life in general. There is a lot of competition, and not all the competition is healthy, and that's a fact. Maybe the discouragement that I had was when I had my baby at the last year of my PhD. Almost everyone that I know told me that I'm going to quit the PhD. Okay, that they told me you can't do it. You need to finish your PhD. You still have a new baby, and actually at that time, my husband got appointment at University of Maryland, College Park, and I was at UCLA. Okay, so I had to move at my last year of my PhD with a newly born baby, just 1 month, to Virginia. Okay, and I had to finish my PhD at that time in order to graduate. And I took it as a challenge for me that everyone around me told me, okay, that's enough. Maybe you can finish with masters. Maybe you can just like end your PhD now and you don't have to do the final part of your thesis. You will not have time. You don't have the energy. And this like stereotype that women with new babies cannot focus and they cannot do a logic. And this annoyed me. Okay, why are you saying that? Because I have a baby, I can't focus, or I can't do anything that requires logical thinking. Okay, so I took it as a challenge actually, and the last year of my PhD I had papers that are more than the papers that I had before. So and that I was working remotely, not in my lab, and I was working at home with a newly born baby, and my husband was at UMD. So I have to say that I have support from my advisor at that time, and he was okay for me to work remotely, and of course support from my husband. Okay, and I mean, you can't do everything by yourself. You need to have a support system around you, definitely. But I'm saying that if I listened at that time when I was the most vulnerable, I just had a new baby, and listened to people who are saying, okay, just give up and that's enough, and you don't have to get a PhD degree. Okay, that was a moment that I decided I'm doing the PhD for myself. I'm not doing it for others. Then I have to continue, and that's what inspired me, that the PhD at the end is a personal success. I'm not doing it for my advisor. I'm not doing it for my family. I'm not doing it for, it is a personal, it is my PhD. So I took it as an inspiring thing for me, that at the end, I'm going to own the success. So I have to work for it. So yeah.
That's incredible. Thank you so much. So just because we do want to allow ample time for the panel, we're going to go ahead and skip 2 questions. So we'll skip this one and the next one. And we'll go ahead and jump into something that has already been discussed, which is, have you had any mentors, or have you yourself been a mentor figure at any point throughout your career?
I think by default, you kind of have to be, whether you are a good mentor or a bad mentor. That's a question. Naturally, that's something you have to be when you have, graduate or PhD students that you have to supervise and guide along. And I have noticed you first, it very much varies, but for some you kind of become a third parent. For others, you become like a colleague. And then for others, again, it's like a business transaction. That's really unique to what type of student you are and mentorship you allow or want, because you can only mentor as much as the person, you know, wants to be mentored or wants to be personal or open up. Yeah, I have to say, with all my mentors that I had during my life, like my you know, doctoral advisors, or also other people, friends, it was helpful to have, for all life questions and questions with long-term perspective, it was good to have someone that's substantially older than you are. So that's, you know, like Salma said with the, you know, if she would have asked one of her friends, you know, about the whole baby situation or having kids early on, it's you can never get the same perspective as like someone else who can see it a little bit more relaxed and is not standing with you in that stress. So yeah, get a mentor, at least one of your mentors that's twice as old as you are.
Yeah, I think absolutely people who are successful are never successful because of only their own efforts. So yeah. I have a long line of people who I'm eternally indebted to, who saw something in me before I saw it in myself, or before I even realized, you know, that this was an option for me. One person I can think of is this graduate student who was in the lab that I joined as an undergraduate. He encouraged me to apply for fellowships, scholarships, apply to grad schools. I didn't really think I was that caliber student, and he saw that I was. And so he encouraged me to do that. And otherwise I wouldn't have really sought it out on my own. So I think there's often questions that students ask about how you get a mentor. And from my experiences, it was all because of being willing to show up in people's offices, or now in their Zoom offices, show up in class, ask questions. You have to put in the effort to stand out, and that can feel difficult. But right now, actually, it's not that hard. Having taught remotely now for 3 quarters, the students who come to my office hours and turn on their camera, they stand out to me. And the students who come to my office hours and ask questions regularly, they stand out to me. Or if I'm lecturing and there's a student who will turn on their camera, even if sometimes they look sleepy or sad or whatever, that really stands out to me. And then I'm motivated to help that person. So when they come to me for a letter of recommendation or advice, I already feel this personal connection with them. I'm able to help them a lot better. So I think if you're wondering how to find a mentor and feeling really disconnected right now, try to connect with your instructors and see if that improves things.
We can skip to the next question for the sake of time if you want to.
Okay, thank you. So I believe this is our last question, which is, what advice do you have for younger female engineering students and students interested in your particular field?
I have one thing that it goes along with what was said earlier, but it does help. If you're young and you're good, it is easy to compare. It's easy to feel insecure. Or one thing that helps, have clear goals and clear achievable goals. Otherwise, you will always compare yourself with everyone else out there who is already so much more. You'll always feel inferior. And I think making a strategic plan for like your professional kind of time frame, whether it's to graduate here, to get your license within this year, get the next professional license in that year, to reach out and work on XYZ projects, It kind of keeps you on track. And once it's accomplished, it actually, you can look back and it's a measurable something. It's a measurable outcome that can keep you going. One more thing is, what has helped me is to attend, well, right now it's a little weird, but professional events like talks, seminars, workshops, and like as Stacy said, be really proactive about it. And naturally, if you're in an event with a lot of with a lot of males, you're being noticed as a female because there are only so few of us in those kind of settings. But I think we can almost take that to our advantage, and have good conversation and good collaboration, and show that we're technically competitive. Another thing that came to my mind, in terms of career development, go and apply for as many awards as you can. Don't wait until someone nominates you, because maybe sometimes people don't even know or don't even see how good you are. And it's just such a hurdle to overcome and say, you know what, I think this award would really fit me. Would you be willing to nominate me? And who's going to say no? Like, people are not going to say no. They're going to say, oh, let me see why, and then most people are willing. It's more us that are afraid to say that, perhaps because we don't feel like we are good enough and no one externally does it. But especially in the very beginning, just be bold and go for it. It pays off in the end. So yeah, maybe I'll think of a few more, but that's what came straight to mind for, at least, in the civil engineering field, and how to get a good visibility.
For electrical engineering and computer engineering or computer science, my field is very fast-paced, so you have to be flexible. So maybe the thing that is a hot topic now, 2 years from now, it's not a hot topic anymore. So I know that this is for undergraduates. So for example, when I was at your age, machine learning was not a thing, okay? And there was some courses about AI and knowledge base and but there isn't the notion of machine learning, and this booming of machine learning was not a thing at my time when I was an undergrad. Okay, so I started to work as a circuit engineer and in CAD companies. But if I got stuck in that and I didn't try to improve myself and keep with the pace of the new technologies and the new research and the new hot topic, I will always be stuck in a very old topics that there may be no job market for it anymore. Okay, so 2 or 3 years ago, people who just know the word machine learning was directly hired. Okay, now if you really don't understand the concepts or the theory behind machine learning, you will not find a job in machine learning. Okay, and that's because there are a lot of people now who knows machine learning, so you have to keep with the pace and maybe push yourself forward towards what is currently is required in the job market for undergraduates, not just for job market, even in research. If I kept myself in a particular topic and focused on it in my field, like I mentioned, my field is very fast paced, so if I just focus on one thing, after 5 years from now, it will die out and nothing will come from it. So at the very first 2 years of my PhD, I worked in mobile computing because mobile at that time was like the new sensor modality, and it can detect a lot of things and it can leak a lot of information, and it can get you GPS location and a lot of things that came up from mobile computing. And a lot of conferences actually came out from mobile computing and job market, okay, just on mobile computing and Android development for undergraduates. Okay, now it started to die out. Okay, so you need to always like be sharp and always try to look for what is new, what is a new technology, what is the thing that I need to learn. And as engineers in my field, I don't think that there is at any point in time that you will stop learning. Okay, so don't think that after you finish your bachelor degree, that's it, and I'm going to work, and yeah, that's fun, and that's it. You need to always learn in order to find yourself in a higher places in the job market. But if you just stop learning after your bachelor degree, you will be stuck with the technologies and the things that you learn at 2021. Okay, so my advice is always keep learning, always look for what is new, what is the new things that people are trying to understand and learn. And even if it is a struggle for you to understand, but I mean, try and challenge yourself to understand new things even after you graduate.
Have you read the book Mindset, Salma?
No. Send it to me. What
Like
is it?
Does anyone know the book Mindset? No, it's very good. It describes those two types of thinking. The very progressive type, that is kind of what Stacy also said, where you fail and you learn from it, but you use it as an encouragement and you keep going, versus the mindset, I know something and I need to protect that knowledge, and I am resting in that knowledge, but it kind of makes you lose the next step forward. It's very well explained. So
send it to me. Send me its name. Yeah. Yeah.
I think Anne mentioned this before, that there are these studies that show that men will apply for a job or an award or a promotion when they have checked about 60% of the boxes, and women will apply when they've checked about 100%. I was trying to find the study and I can't, but I'm putting a link in the chat to some article about it in Forbes. In any case, if you don't know this yet, you should know this. So I always tell my female mentees this, because it's just the way that on average we're programmed, for whether it's socially or biologically. We don't need to get into that discussion, but you need to know the people you are competing with, who are largely male, right? They are much more confident than you, and they will apply for things well before you think you would be qualified to apply for. So I think it's important for women to understand that, and to try to promote themselves, to try to apply for things when they don't quite think that they have all the qualifications. So actually try to do the numbers. Like if you're applying for jobs or internships, go through the list and count how many you can do. And if you've reached 60%, apply. Even if you reach less than that, apply, because it's a stochastic process. So I think that's good advice for everyone who's a woman and trying to excel in a career. And for students interested in material science and engineering in particular, I think I would encourage you, come learn more about it. It's really exciting. And there's a ton of new, really exciting developments happening in how we're able to image materials at the nanoscale. You know, we can now see specific atoms. We can manipulate materials by, you know, not with our hands, but in certain ways, moving atoms and controlling the behavior that comes out of those. And I think it's a really exciting discipline, both for people like me who are just giant science nerds and really love the science, and this is what drives us, and for people who are really driven by specific applications. Because at the end of the day, if you think about any kind of technology, there's pretty much always a material involved, right? Like in your phone, there's all of these semiconductor chips that have taken decades of work by millions of people. New biomedical devices all involve materials. New structures that people are building, right? They all involve materials. So you can go in a lot of directions with a degree in material science. And also it's just a lot of fun.
So I want to add something here is just to what Stacy and Anne mentioned about that men usually go for things even before female things about it. So I was involved in diversity and equity inclusion, the main representative for Howard Hughes Medical Institute when I was at Genelia. And we noticed something that caused inequity in the salaries between men and women, is that usually men go and ask for promotion and ask for a raise and ask for more off time. And I did this, and this project succeeded, so I need a raise. And they noticed that women don't do the same. So what happened when people didn't do this analysis, what happened is that there were like this huge gap between men and women in the salary, and then the advantages that they take, and all of the facilities and things that they get from work, because women never asked. So what happened is that we recommended for the managers that they have to go back and check everyone who is taking what, okay, and to make this kind of equity in the salary. But that was really hard on the managers to do, because that required a lot of effort and going back in history and why this person got a raise and this person didn't get a raise. And the end conclusion for that was that because men asked for it, and women was always have this imposter syndrome that they are not good enough. If they asked, they will be rejected, that they maybe they are not good enough. Maybe if they ask, they will say, no, you don't deserve the raise. So they always hold back. Okay. Yes, go for the opportunities, and don't say that I'm not good enough. I mean, what is the harm? Go for the opportunity, even if you don't get it. What is the harm? Okay, but if you don't get the opportunity because you don't ask for it, don't blame yourself. Okay, so you have to ask for the opportunity. You have to take it. You have to believe in yourself, and see what your male peers are doing, and don't hold yourself back.
That's fantastic. Thank you all so much for your wise words. It's been so insightful hearing everything. So thank you so much. We do have some time to open it up to the audience. So if you want to use the Zoom feature of raising your hand, or if you'd like to ask a question in the chat, you're more than welcome to do so. Yeah, Pasha, go ahead.
Hi. So I have a really quick question about when you were talking about mentors and stuff like that. So reaching out to professors, reaching out to like people who are in your field that are like steps ahead of you, so you can to figure out where you want to go, or to figure out if you want to like even work with them at all. Doing that for me at least was difficult and a little scary, I guess, especially when I was in person, and especially now in Zoom. It gets even harder. So like as faculty right now, how do you like imagine or like prefer like students coming up to you and like asking for advice or asking about your work or something like that?
I think one thing that really stands out is when a student will just turn on their camera, because a lot of the time it just feels like we're talking to these black boxes. And I know Zoom lectures are recorded, so if you feel more comfortable sticking around after a class is over and then turning on your camera when the recording stopped, or if you go to an office hour and you just turn on a camera, I think humans are wired, right, to respond to faces. So it's very biological, even though you might feel like your professors are robots. We're not. We really do enjoy, most of us, seeing humans who we're teaching. So if you're feeling intimidated, I just encourage you to try that one click. Just click and turn on your camera if you have a camera. If you don't have a camera, then we can talk about that too.
There was a question in the chat that asked advice for students torn between going to industry and getting a PhD who enjoy both research and applications. So that's open to anyone.
You can always get a PhD and still work in industry because there's so many jobs out there that really value employees with research capabilities. In civil engineering, for instance, one of those is companies that specialize in litigations and failures, like huge construction failures and so. And so you need a person that is able to have this research skill to figure things out. And that is a unique asset that you learn during your PhD, more so because you're forced to. And I believe a lot of companies value that. Don't think that a PhD will limit you to an academic career. I think it is an exercise of endurance. It's not like you need to have a 4.0 GPA. You need to have the endurance and the willingness to learn. That is the most important thing. But if you have that, then you develop skills that, go far beyond any of the skills that you develop during a regular master's degree. And that's how you're gonna become very valuable, regardless of what path you're gonna take.
Yeah, so PhD is a journey, okay? So it is in my field, it's a 5-year commitment at least, okay? So unless you are motivated that you really want to do a PhD and you really like research, it will be a torture, to be honest with you, because you don't get paid that well. You work so much. Sometimes you will get a lot of rejection letters for some of your research. So what I always say, like the 3rd year of the PhD or like 2.5 year PhD, I call it mid PhD crisis, right? Because because at that time, you will doubt what I'm doing. Okay, my peers at the same time, who graduated at the same year, are well established in industry, are getting much more paid than me, and I'm getting a rejection letter for my research. What I'm doing, okay? So unless I always say that to anyone who asks me whether I should take a PhD, should I go for a PhD or not, you have to really be motivated. Okay, you really should like research to do a PhD. Okay, however, if you do it, it will pay off at the end, not just for academic position, but also for industrial position. You will see in my field, for example, if you want to go to Facebook research, Microsoft research, Google Minds, these places, Intel research, Samsung research, Janelia research, these things only accept people with PhDs. Okay, so it requires students with a certain critical thinking that you will not get this training unless you are from a PhD. Okay, so it is a hard journey. It's not, I can't lie to you, it's not an easy journey. Okay, it is a hard journey, but it pays off at the end. So unless you are really motivated and you really like research, then I don't advise it to everyone. Okay, but you really should look at even, so I have, for example, I have an undergraduate researcher who works for me who is bright. Okay, and he doesn't want to do any research. He just wants to finish his bachelor degree and goes to work as an engineer in Apple. Okay, and I really feel so bad because he can be a successful PhD student. So what I showed him is just the positions at Apple, where he is really fascinated of and he really wants to go there. I showed him the different job applications for people with a PhD and people with a bachelor and people with master's degree. Okay, and I told him compare. I mean, you can see the difference between what is the job for a student with a PhD and a job for a student with just bachelor. I'm not saying that just bachelor is not enough. I'm just saying if you put this extra effort and you are willing to spend 5 more years into this training, it will pay off at the end.
Not necessarily in salary, but
no, it's not.
I think that I want to also make a plug that there's a kind of an in-between between academia and industry, which is the national laboratories. Both Department of Energy and Department of Defense and other national laboratories as well, or federal laboratories. And in these places, in some of them, they're very much like industry or focused on making a product and maybe your customers, the federal government. But in some of them, it can feel a lot more academic. And also you have this, mission of whether it's national security or of energy security for, say, the power grid, or things like that. People who work at the national labs really like having that big mission as part of their career. And so it's a good option as well. And there are options at national labs for people at all levels with engineering degrees, but also many positions for PhD. And one last thing is that there are a lot of people that are going to be retiring soon and are retiring now. You can't really see it in academia because people don't really retire, they just kind of die. But in the national labs in particular, they need to hire tens of thousands of people to recruit or to replace all of the baby boomers who are retiring. And that's not going to change no matter what happens to the economy. And I heard those words out of the mouth of the deputy director of Los Alamos National Lab. So there will be a lot of job opportunities at the national labs in the next decade.
Thank you all. I noticed that it is past 7 o'clock and we do want to be, of course, respectful of everyone's time. So thank you again so much to all of our incredible speakers. It was lovely hearing from all of you. Thank you so much for taking time out of your day to be with us. And thank you to those that attended as well. We hope that this was an insightful event.
Oh, I think we wanted to take a picture of all the peers, panelists, as well as any audience members who would want to be included in the picture as well. It's up to you. But if it's possible for everybody to like open their cam so we can take a screenshot and save it for memories. Brenda, would you like to take this screenshot or should I?
Oh, yeah, sure. I think I know how to do it.
Okay.
Okay. All right, so 3, 2, 1. And one more. 3, 2, 1. All right, thank you.
Great to see everyone's faces. I hope to someday meet all of you in person.
Yeah, definitely.
Yes, thank you again. Take care, everyone. Have a great rest of your evening.
Bye.
Yep.
Thank you, everyone.
Good to meet you, Salma and Stacy. Now that
Nice.
we could have no official welcome at UCI in the very beginning when you arrived.
Nice to
Maybe
meet
we
you
can
too,
get
Anne.
together once things are back to normal. So this was great of the students to make this introduction for us. So awesome, thank you.
Yeah, thank you. Hopefully we can connect, Anne. Take care.
Yeah.